All right, hello everyone. This recording is for Wednesday, April 15th, 2020, and this is one more recording for reporting category 2 that we've been working so hard on the last 2 weeks. So today we're going to be reviewing expressions, equations, and relationships. We're looking at how to identify and verify the values of x and y that simultaneously satisfy two linear equations in the form y is equal to mx plus b from the intersections of the graphed equations. So we are looking at systems of equations today. So I want you to examine the systems of equations in each box and determine which color to shade it. So press pause and work these out, and then press play when you're ready to go over the answers. All right, so remember, when you are solving for a system of equations, you are going to set those equations equal to each other. So here for the first one, we have 3x plus 4 is equal to 3x plus 8. We're going to subtract 3x on both sides. So 3x minus 3x is 0, so that cancels on both sides, leaving us with 4 is equal to 8, which that is not true. So this one is a no solution. Okay, moving over to 3x plus 4 is equal to 3x plus 4. If we subtract 3x on both sides, that cancels. 4 is equal to 4, which is true. So infinitely many solutions. It doesn't matter what we plugged in for x on this one, since x would always be the same thing, these would always be equal to each other. So this one is infinitely many solutions. We could have any value of x to make that equation true or system true. And we have 3x plus 4 is equal to 4x plus 3. Let's subtract 3x on both sides, leaving us with 4 is equal to x plus 3. Then let's subtract 3 on both sides, leaving x by itself is equal to 1. So only one solution would make this system true. So this one is one solution. We would have one intersection on this if we graphed these equations. And the last one here, negative 2x plus 3 is equal to negative 2x minus 3. So let's distribute here first. Let's distribute that minus sign to everything inside those parentheses. So negative 2x plus 3 is what we're left with. Now we can solve. Let's subtract 2x on both sides. So negative 2x plus 2x would cancel each other out, leaving us with 3 is equal to 3. So we could plug in any value for x here, and these would be true, so these would be infinitely many solutions. Okay, so now that you've got the hang of this again, page for me. Press pause and then move forward when you're ready to go over the answers. All right, let's see how you did. So negative 2x plus 3, we're going to set that equal to 2x plus 3. Let's start by adding 2x on both sides. So when we do that, we're left with 3 is equal to 4x plus 3. So let's subtract 3 on both sides as well, combining all those like terms. So 3 minus 3 is 0. So that cancels everything out over here on the left side. And 2x plus 2x is equal to 4x. So then we could divide by 4 on both sides. So x would be equal to 0, leaving us with just one solution. When we graphed these two lines on a graph, we would have two lines that intersect in one place. So we would have one solution. All right, so two lines with different slopes. So I just drew an example. So here we have a line with a negative slope, and then I drew us a line with a positive slope. Those would cross in one place. Those would intersect in one place on the graph. So this one is a one solution. When we have two lines with the same slope and different y-intercepts, okay, so if I just had my graph here, and we have two different slopes, or sorry, the same slope, but they are crossing the y-axis in different places, that's going to create two parallel lines. And if we have two parallel lines, that is no solution. They are never going to cross. Then we have two lines with the same slope and same y-intercept. That means we're going to have the same line. Okay, it's going to be one line on top of the other line. And so infinitely many solutions is the answer when we have two lines that are the same line. All right, keep it up. Try this page. Press play when you're ready to go over them. Okay, two lines that have the same equation. So we've done one already on the first page that was two lines with the same equation. So I just pulled that work to prove it again. So if our equation was 3x plus 4, 3x plus 4, if it's the same thing on both sides, that's always going to be infinitely many solutions. We could plug anything in for x there, and the answer would be equal to each other. Two parallel lines, we talked about that on the page before. Two parallel lines is always no solution. When we have two lines that cross only one time, that is one solution. And then y is equal to 0.5x plus 6. So this looks different, but it is the same thing. We know that 1.5 and 1/2 can be written the same way. And then 6 and 6.0, that's the same thing as well. So basically here again, we have two lines that have the same solution. So this one is also infinitely many solutions. All right, you are doing great. We've got of problems. Give these your best shot and press play when you're ready to go over them. All right, so 0.5x plus 6 is equal to 0.5x minus 6. If we subtract 0.5x on both sides, that cancels, leaving us with 6 is equal to negative 6, which is not true. So this one is no solution. 3/8x minus 5 is equal to 2/3 30 over 45x plus 45. So I went ahead and simplified these fractions here just to kind of make our lives a little bit easier. Then I subtracted 2/3 x on both sides. So that would leave us with 1/12 x is equal to, I also went ahead and added 5x on both sides. So negative 5x plus 5x cancels on the left, but what you do to one side, you have to do to the other. So 5 plus 5 is equal to 10. So 1/12 x is equal to 10. I can either divide by 1/12 on both sides or multiply by that reciprocal. So if I do multiply times 12 over 1, that would cancel on the left. 10 times 12 over 1 is 120. So x would be equal to 120, leaving us with one solution. That one was a tricky one. Those fractions can kind of throw us off, but solve the same way, guys, you would if it was a whole number and not a fraction. Follow those same steps. And then we have 5x minus 6 is equal to negative 20 minus 4. I started here by adding 20x on both sides. I also added 6 on both sides. So negative 20 plus 20x cancels, and negative 6 plus 6 cancels, leaving us with 25x is equal to 2. Then I divide by 25 on both sides, so x is equal to 2 over 25, a fraction. That is still one solution. A fraction is still an amount that we could graph. And our last one for today, 2x plus 8 is equal to 4x plus 16. So I'm going to subtract 2x on both sides, leaving me with 8 is equal to 2x plus 16. Then I subtract 16 on both sides, leaving me with 2x is equal to negative 8. Divide by 2 on both sides, leaving me with x is equal to 4, so one solution. All right, job, guys. I hope that was helpful for you with a quick review on solving systems of equations. Remember that I have office hours on Wednesday at 12:30, so that's like Health Lab. If you need some extra help, come see me there. Your assignment for this week is in USA Test Prep. That is 13.02B quiz, reporting category 2 review. Remember, we are just doing one assignment per week from now until the end of the year, well, until May 8th. So make sure you are working on any missing assignments that you have. If you have completed all of your missing assignments, remember you can do that error analysis form for any assignment below 80%. So let's make sure we're working on all of those things. We're finishing strong. I keep it up and have a great day.